All right, we're looking at the topic 9 review. This is over proving that triangles are congruent, looking at the postulates. And so at the beginning here, it says name the congruent parts of the triangle and write a congruent statement. So we're giving you two triangles where everything is marked. And this is just kind of a little warm-up here to make sure that you can tell me which parts match up together. So because every single part in both of these triangles are the same, we know that the triangles are congruent, obviously, because everything is the same in all of them. The point is which angles are the same and which sides are the same. So you're just looking for the same markings. So I see on D I've got a single angle marking, and then on K I've got a single angle marking. So because D and K both have a single angle marking in geometry, that's how we signify that they are the same degree. And then we look at the same thing on E and J. Both E and J have two angle markings, and so I know that E and J match up together. They're the same. And the same thing with F and I. F and I are both the same because they both have three angle markings. Now, it's not just the angles that are the same. The sides are the same as well. And so I see DE. DE, this line segment, has a single marking. So I know that line segment DE is congruent to KJ, which also has a single marking. And then EF has two markings on it, as does JI. And DF has three markings, as does KI. So these problems are just kind of a warm-up, just trying to get you to match the parts that are the same. And in geometry, we denote that parts are the same by using the same markings for them. Typically, it's a little curved line for the angles and a little straight tick marks on the sides to show. So you can do the same thing on 2. Goes pretty quickly once you know what you're doing. So B and L have one marking. Those are angles, so I'm going to use the angle symbol. A and M have two markings, and C and N have three markings. And then on the sides, I've got AB has a single mark. It's congruent to ML, which also has a single mark. MN, well, I'm going to be consistent, I'll put MN over there. So MN has two, as does AC. And BC is the same as NL. Okay, that part's pretty simple, just matching up parts to get started. So now, here's the kicker. What we're looking at in this unit is proving that triangles are congruent. So questions 3 through 8 say, are the triangles congruent? Tell which congruence postulate proves it. So we're not interested in identifying every single part that matches up. What we're interested in is, do we have enough information to prove that triangles are congruent? Now, that doesn't mean that you look at them and say, oh yeah, they look like they're the same, or yeah, they look like they're the same size. What you're doing is you're proving it by identifying how much information is necessary to show that those two triangles are the same. There are 5 postulates, which you should have looked at in class, that give enough information to prove that a triangle is congruent or to another triangle. So for example, if we know that all 3 sides of 2 triangles match up or are the same, then we know that the entire triangles are congruent. So if we know all 3 sides, it doesn't matter if we know the angles or not. If we know all 3 sides, that's enough to prove that those 2 triangles are the same. If we know 2 sides and the angle in between them, that's enough to prove that 2 triangles are the same. You don't need to have all 6 things marked on 2 triangles to prove they're the same. Now, you need more than one thing, but you don't need all 6. So we only need 3 sides, or 2 sides and an angle in between, and you should have gone through and proved why all of these work earlier on your own, but this is where we are now. You can also prove it if you've got 2 angles and the side in between them. So if I've got 2 angles marked like this and the side in between them, and it's the same thing on another triangle, then I know the 2 triangles are congruent. So this is less information, but because of what it is, it still proves that the triangles are the same. If I've got two angles and then a side, which is different, so it depends on where the side is. Is the side in between the angles or is it after the angles? Either way, it proves the triangles are congruent. And then finally, I've got what we call HL, which is a special marking. It's a right triangle, a hypotenuse, and one of the legs, either one. And as long as you've got two triangles and you have those three pieces of information, that also proves that two triangles are congruent. But it has to be a right angle. It can't just be any angle. It has to be a right angle in this particular situation. Anything else that's not these does not prove that triangles are congruent. Now, that does not mean that they are not congruent. It simply means that we can't prove it. So this is not about saying it is or it isn't. It's about saying, can we prove that it is? So on number 3, I've got a side marked, I've got an angle marked, and then this side here isn't marked, but they don't have to mark it. That side is a part of both triangles. So because that side is a part of both triangles, it should be obvious that it's going to be the same length on both because it's the same line. So we use this term called the reflexive property to denote that that line, or that line segment, will be the same on both the top triangle and the bottom triangle because it's in fact the same line. So we use a mark to show that it's good for this one, but it's also good or the same for this one. So I've got a side followed by an angle followed by a side on both triangles. So because they match up, SAS, side, angle, side, my question now becomes, is this enough information to prove, because remember, we're trying to prove that the triangles are the same. And that is enough information because it's one of the postulates that I've said from the beginning that you guys have studied in class that show or provide enough information. So SAS does work. It does prove that triangles are congruent. So are the triangles congruent? Yes. Tell which congruence postulate proves it. SAS. Okay, number 4, I'll go in numerical order here. So number 4, we've got the same thing here, reflexive property for that line. You don't have to have it marked for you to know that it's the same on both because it's the same line segment. So I've got a side, and a side on this triangle that match a side, and a side on this triangle. So is that enough information? 3 sides, is that enough? And I look, yes, it is. It's one of the ones that is enough information to prove the triangles are the same. So are the triangles congruent? Yes. Tell which congruence postulate proves it. Side, side, side. So we go down to number 5. Now number 5 shows a different relationship that's not marked. I've got an angle here, an angle that matches. I've got a side here and a side that matches. Nothing is marked here, but we should have known from a long time ago, one of the first units, we talked about vertical angles. So because those lines because those angles intersect at a line, then I know that they are congruent. They're called vertical angles, so this angle matches that angle. So what I've got in this picture is an angle followed by an angle followed by a side. And that matches this one, which also has that angle followed by that angle followed by that side. So 2 angles followed by a side. 2 angles followed by a side. Now that is one of my postulates. It's this one here. And so again, is this enough information? Yes, the triangles are congruent. The postulate is AAS. All right, number 6. We've got an angle here that matches an angle there, and we've got an angle here that matches an angle there, but in between them, this side is the same. It's a part of the left triangle and the right triangle. So the reflexive property, again, I can mark that as the same as well. So I've got an angle that matches this angle, a side that matches this side, and another angle that matches this angle. So ASA, 2 angles and a side in between them. This is on my list. So yes, the triangles are congruent, and the postulate is ASA. All right, finally, number 7. Finally, I don't know why I said finally, there's another one after that, but number 7. I've got everything marked, so I've got an angle here that matches an angle there, a side here that matches a side there, and another side here that matches a side there. And my screen went out. All right, I'm back. All right, so in this particular picture, I've got an angle followed by a side followed by a side. Or you could say, you could read it the other way. I've got a side followed by a side followed by an angle. Either way, side followed by a side followed by an angle, you can see why I'm not writing it the other way. This is three things, or three markings, but it's not three markings that prove that the triangles are the same. It's possible to have those three pieces of information in two triangles that are not the same. And so, again, we're not saying that the triangles are not congruent. We're just saying that we can't prove it. Maybe they are, maybe they aren't, but this is not enough information to prove it. So I'm not going to say no, they're not congruent. I'm going to say not enough information. Okay? This is not saying they're not congruent. It's simply saying that we don't know yet. And so that by itself is not enough. I would need another mark to prove that they were the same, because what I have is not enough. Because this is not a postulate. And then finally, number 8. I've got a side that matches this side, another side that matches this side, and an angle that matches this angle. Now, on surface level, it looks like SSA, which we just said doesn't work. It's not enough information. But we have to pay attention to the fact that this is a right angle. And because it's a right angle, we've got this special fifth postulate here that's only for right angles. And if we have the hypotenuse and the leg, we're good. So here's my right angle. This side right here is the hypotenuse. And their markings are the same. And this side right here is a leg. And it matches that leg. So because we have a right angle, we can also look for HL, which is a part of that SSA, but because it's a right angle, it's allowed. So HL is a postulate, so we can say yes, HL proves that they are the same. So side-side angle doesn't normally work, but if it's a right angle, we've got that HL postulate that does prove it, that we can use. All right, so now we're getting into the fun stuff. This is where you actually have to kind of reason through. Now, a proof is nothing more than you telling me something and telling why you said it. So you're going to give me a statement, anything. It's raining. And then what's the reason? How do you know it's raining? Because I went outside and I saw it. You know, like, how did you know that it was raining? How did you know this? How did you know that? So the first thing that you're always going to tell me in any proof is what was marked or given for you. So in the picture, I see that A, B, and C, D are marked. Okay, I didn't measure it myself. That was given to me. It was told to me. I didn't have to do anything to prove it by myself. So my first statement is going to be that AB is congruent to DC. Now, if you didn't do it yourself, in the reason, you just put given. You say, basically, somebody gave it to me. They told me that already. So we always start with that kind of a statement. Now, read the next thing. It says AC is congruent to AC. So let's look at the picture. That would be AC, this line right here. Now, why would it say AC is congruent to itself? Well, because it's a part of this triangle, but it's also the same part of this triangle. So because AC is a part of both, it's listed twice, and that property that we've talked about a few times on the page before, the property that proves that is called the reflexive property. So you're just stating the reason that you know that that's the same. Sounds pretty obvious because it's the same line, but the way that we phrase it is called the reflexive property. Now it also should have had probably a statement up here for given that angle B and angle D are the same as well. It's not listed, but we can see that in the picture. So given the information, whether or not they made you write that up here is okay. I've got a right angle, and I've got the hypotenuse, and I've got the leg. So if I have a right angle with the hypotenuse and the leg for both triangles, I can prove that the triangles are the same. So your last step, your first step is always the given, your last step should always be what you're proving. And if you're proving that triangles are the same, you always need to use one of those postulates that we talked about, SAS, SSS, ASA, AAS, or HL. So this one is HL. So we're just doing the same thing we did before, but we're actually writing down the reasons. We're not just putting an answer. We're actually putting the reasons that lead up to the answer. So it's like showing your work, explaining yourself. So I've got given 1, 2, three things. So there are three things. Here's the first one. Here's the second one. They're already written for me. The third one is not written for me. So C is midpoint of BE. I'm having to abbreviate because I don't have much room. And then all three of those things were given to me. So you can literally just write given, given, given. This problem told you a lot of things. And that's okay. It means the proof is going to be a little easier because you didn't have to work for those. Those were given. Now, what do we need to work for? There's only two markings. We need at least three markings. We know that everything needs at least three to prove they're the same. So the third marking is based on this last statement. If C is the midpoint of BE, if C is the midpoint, then don't we know that this side is the same as this side, right? So I'm going to mark this side and this side the same. And if those sides are the same as well, that would be BC is congruent to CE. Then I can go ahead and write that as a statement. BC is congruent to CE. Now, how did I know that? Well, I know that because I know what a midpoint means. That's why it says definition of midpoint. The fact that this is a midpoint should have clued you in to the fact that these are the same. So that's your reason. How did you know? Because it's a midpoint. And then finally, is this enough information to prove that the triangles are the same? So my triangles are the same, just like I did on the page before, because I know that if I have a side, an angle, and a side that matches up for both of them, then that's enough information based on the side, angle, side postulate. All right, number 11. I have two statements that are given to me. SP bisects QT. They already wrote one of them, but they didn't write the first one. So I've got a given statement here, followed by a given statement here for this one. That part's what's told to me already, so that's the easy part. Now from there, I need to see, notice I don't have any markings in here. There's not any particular order that you have to go in, but since they've already filled in some of the blanks, I need to kind of pay attention to what they've filled in and make sure that I do the same thing. So I noticed down here on number 5, it says vertical angles. I know what vertical angles are, so I'm going to go ahead and fill that one in. Vertical angles are these right here. And we've talked about why. So I'm going to go ahead and just say that this angle, which is QRP, or maybe you said PRQ, it doesn't matter, angle QRP is congruent to angle SRT, or you could say TRS. So how do I know that those angles are the same? Because I know what vertical angles are. You could put definition of vertical angles, or you could just write vertical angles. That's how I know they're the same. Now, I was also told that two things bisect each other. So this line bisects this line and vice versa. So that means that these marks should be identical because bisect means to cut in half. And these should be identical for the same reason. So both of these are bisected, so then I'm going to have definition of bisect twice. Whoops, I almost wrote dissect. Definition of bisect. So now what two things are the same because of those bisections? They wrote PR is congruent to RP, which that should say RS. PR is congruent to RS. That's what that should have said. Now I also have this segment that's cut in half. So QR is congruent to RT, and that would be the exact same reason. So on this one, to kind of break it apart, make it easier, you've got two given statements. You've got two things that are bisected, same reason, two separate things. You've got a pair of vertical angles, and that all leads you to prove that the triangles are the same. So I've got a side that matches a side, an angle that matches an angle, and another side that matches a side. So I've got SAS, side, angle, side, which is already written. So that proves that triangle, and I'm just going to take it straight from here. Triangle QRP is congruent to triangle TRS. That's the whole goal, is how could we prove that? And we've done that. All right, last one of these where it's kind of filled in for you a little bit. I was given two statements. So the first one's written, the second one isn't yet, so I'll go ahead and write the second one down. And these were given to me, so I didn't have to earn them, I just had them given from the beginning. Now that's only two things. There needs to be one more thing somewhere that I should be able to mark if I want to prove anything. So I see in the middle, I can always look for vertical angles. That's a pretty easy one to find usually. So when you find vertical angles, go ahead and say that MPL is congruent to NPO. And then we know that's vertical angles. And then because I've got AAS, that proves that the triangles are the same. So MPL, triangle MPL is congruent to triangle OPN. Now this one goes a step further. It wants to prove that L is congruent to N. Now we know that if triangles are congruent, then based on what we looked at on the first page, if triangles are congruent, everything's congruent. So that is called corresponding parts of congruent triangles are congruent. Now it's a mouthful, so we don't write all of that. We just abbreviate. We say CPCTC. Corresponding parts of congruent triangles are congruent. In other words, if you can prove that the triangles are congruent, you can prove anything inside the triangle is also congruent. So that's what we're stating here, is that if they're congruent, so is everything else. And then our final steps here, we've got some that are just open-ended, so we can work through them. The first one is kind of self-explanatory because you're given all three pieces of information by yourself. So I can write all of these down as statements. They were all given. I didn't have to earn any of that. So those are all free. And that's enough by itself. I was told all three of these, which are all three sides. So I can prove that the triangles are the same by SSS. And I'm done. I've proved what it told me to prove because they gave me enough information already. I didn't have to do any work on that one really. 14. I've got two things that are given. And unfortunately, neither one of those actually gives me anything to mark. But it does help me. So how does it help me? Well, I know that bisect means cut in half. So if LP bisects MO, if MO is bisected, then I can mark those. So I can say ON is the same as NM. Definition of bisect. So definition of bisect, or you can just write bisect. Now it also says that LO is parallel to MP. So if this line is parallel to this line, remember we have these things that we called alternate interior angles a long time ago. In another unit you looked at parallel lines and you talked about different relationships. One of them was alternate interior angles. So if you're told that things are parallel, you can mark alternate interior angles like L and P. And you can use that for the reason. And then don't overlook the one that's kind of obvious, but sometimes it's obvious and we don't think about it. Vertical angles in the middle. So LNO is congruent to MNP. And those are vertical angles. So I had to do a lot more work on this one because it didn't give me as easy information, but I still proved that the triangles are the same because I have AS on both of them. So triangle LNO is congruent to triangle MNP by the angle side postulate. And then finally, this one here looks a little bit easier to work with because it gave me 2 marks already. So I can say that MN is congruent to PO and that MP is congruent to NO. Those were both given, didn't have to earn either one of those, and that's 2 markings. Now I need a third marking. So I look at the picture, is there anything else that I can determine on my own? And I see this line segment PN is a part of both triangles. We called that the reflexive property because it's the same part of both. So I can say that PN is congruent to itself. You're writing it once for one triangle and once for the other. And because it's congruent to itself, which we call the reflexive property, I now have enough information to prove that the triangles are congruent. And so I can say that triangle NP is congruent to triangle OPN. Kind of have to follow the letters to make sure you're using the right letters at the right time. And the reason I can prove that is side, side, side. I've got all three sides. Now, don't stop there. Pay attention to what you're proving. You're proving that angle M is congruent to angle O. Now, we just were given the sides. But remember, if the triangles are congruent, everything inside is also congruent part to part. So which angle matches up to M? Well, that would be O. So that proves that M and O are the same because corresponding parts of congruent triangles are congruent. In other words, if we know the triangles are the same, then all the matching parts also must be the same.